Welcome in the fourth section of our course. In this section we'll be solving problems with non-efficient transformation. We will be considering four main problems of Spark. First one is minimizing object creation. So we'll try to reuse existing objects. In the second video, we'll be looking at the iterating transformation. We'll see a map partitions method that is able to iterate over partition. First video will be about Spark application startup. We'll see how to reduce it. And at the end, we will see how to not perform unnecessary computations, and we will be reusing RDDs. And this is a first video in which we'll be minimizing object creation by reusing existing objects. We will see how to minimize object creation by using aggregate by key. This is a very clever method if you want to do some kind of reduce, but we don't care about all elements, but we want to calculate something on a specific executor for a specific partition. We can use aggregate by key and combine results into mutable dataset. So we'll be using mutable state passed to the Spark API. So let's see a test case that will show us how aggregate by key and reusability of mutable state in Spark does look like. Let's say that we are given a matrix data, and this is an array. Matrix data is in case class that has host and response time. Two things, string and long. We have 5 elements of it. Matrix data for localhost, matrix data for 127002, localhost 2 and localhost, and different URL at the end. And also there's a response time here. So first we are creating an RDD and we need to key our data by a specific host, because aggregate by key is an operation that needs to operate on the pair, so key value RDD. At this point we don't have a key for our data set, but calling a key by will create our key RDD, because host will be used as a key. Next we need to prepare for aggregate by key call. So firstly we need to create our array buffer that will consist response times for host, because we need to aggregate response times for a specific host. This will be an array buffer and we are initializing it with the empty, but we can see that this is a mutable data structure. Because of that, we are able to reuse that array buffer instead of creating new buffer every time we are appending elements to it. Next we have a combiner function that is adding our response time, so specific matrix data, to state. And we can see that this is a simple function that just adding matrix data response time to our state. So we need to extract response time from matrix data. Last function is a function that will merge our response times. So we will be having the state for a same key and it could be aggregated in a parallel. So we will get two array buffers, P1 and P2. And we need to combine them, so we are just appending P1 to P2, so we will get an array buffer as a result. Next we are calling the aggregate by key method. First argument is the initialize state, so it is an empty array buffer. Next we need to pass a function that is able to add our matrix data, so value for a specific key, to our state. At the end we need to pass a merge function that is able to merge two states for the same key. At the end we are just collecting our results to list, and we can see that for the host 127002 we have 2 response times. Then for 191001 we have 1 response time, and for localhost 2 response times. So let's start this test and see if our code behaves as expected. We can see that our test passed, so it means that we were able to aggregate response times by a specific key. And we were able to reuse mutable array buffer to overcome extensive object creation in Apache Spark.